Welcome back to Cloud 42, I'm James. Today we are continuing work on the Toolpost grinder. This is going to be part 16 in the series. If you haven't seen the other videos in this series, there's a link to a playlist down in the description, so you can go check those out. Today we are going to work on the drawbar that holds the grinding wheels into the taper of the grinding spindle. Let's go over to the bench and take a look at the plans. This is the drawing for the drawbar. As you can see, it's just over 7 inches long, and it has a register on the back end so that the head of the bolt will center up in the spindle, and then threads on the other end to screw into the tapered part of the arbor to pull it into the spindle and hold it centered. Now, the way I have this drawn here, I had the outside diameter of this at 400 thousandths, and I decided to make a couple of changes because in order to put the flats on this, I'm going to need to hold it in a collet block. And I don't have a collet of that diameter, but I do have a collet that is 7/16 diameter. So I redrew the part, made a couple of adjustments, I added another 50 thousandths in threads. Just after looking at the diagram, looking at the drawings, decided I wanted a little bit more thread engagement. And then I made the body of this 438 thousandths. Which is 7/16. That way I can hold it in a 7/16 inch collet block in the mill to put the flats on it. Now this is the material that I'm going to use. This is 3/4 inch W1 tool steel drill rod. Now I'm not going to heat treat it. There's nothing magic about using tool steel for this. This is just what I have on hand. The rod's not very expensive and I already have it. And even without heat treating, this stuff is going to be really tough and really durable, and it's going to wear really well. It is a little tough to machine. As long as I can run this with run this high speed in the lathe and use carbide, I should be able to get a decent surface finish. The only real question is the threading. I'm planning to single point the threads, and we're just going to have to see how that goes. This is going to be a relatively small diameter, it's unsupported, and there's going to be a lot of tool pressure. I have a carbide threading tool that I'm going to try to use, and we'll see how that goes. If all else fails, I can always just face this off, drill and tap it, and put in a piece of alloy screw and put it in with Loctite if the single pointing fails. But I'd really like this to be a single part, and I can control the concentricity a lot better if I actually single point those threads, because I can dial this in a 4-jaw and then cut the threads with the lathe, the single point tool, and then I know they'll be concentric to the rest of the body. Anyway, let's go over the lathe and get started. Okay, this is the material. This is the 3/4 inch W1 drill rod. And the first thing I need to do is just pop, face off one end and pop a center in it. Now I've got this in the 4-jaw chuck because I want this to run as concentrically as we can possibly make it run. Means now I need a dial indicator. We'll dial this in. Oh. Life is easier when I mount this on the slide, on the cross slide. Everything's good and tight. Okay, there's the low, loosen that. Here's the high, tighten that. That is going to be good enough. Okay, let's grab a carbide tool. And face this off. Running at 2400 RPM here. Okay, let's pop a small center in there. This is a number 2 center drill. And let's not run that fast. Okay, that should be 720. Yep, that's better. Okay. One tiny center. Let's grab a live center and then extend this out for turning. Okay. Not put too much pressure on that. We still have to dial this in. Okay, let's see how close we are. Not super close. Let's make sure everything's tight here. Nice. Now, let's see how far out we are down here if I pull the center back. Not actually moving it, I don't think, here. There we go. There, I'm going to call that close enough. Put the center back in it. Now let's go check down at this end again. And we're pretty much dead on. Yep. Needle's live, so call that good. Okay, let's go back up 2400 RPM so we can get a good clean cut on this tool steel. Now we're at 3/4 and we need to go down to 525. So we've got a little ways to go. I'm just going to start by taking a few cuts at 20 thou depth of cut, 5 thou per revolution feed rate. 520 thou. Before I get too excited, I should probably start thinking about how far I need to cut. So like the shoulder is 6/825. This isn't going to be perfect, but it'll be fine for a scale dimension. That ought to be fine right there. Let's put a little mark. And let's finish that cut. Just breaking the chip. Take another 20. Okay, take 20 more. We're heading for 525. And we're right now at 621. So 96 thou to go, which is 48 off of each side. $596. Going to 525 is 71 thousandths divided by 2 is 35.5. Let's take half of that, which is 17, so I'll take, oh boy, let's go ahead and take 20. Well, let's see here, I don't really want to go in that far. Let's take 10. 577. Which means we got 52 to go. Means we got 26. So I will take 15. Is that right? I don't want to overshoot. 577 minus the target, which is 525, which means I have 52 thousandths to go. Divide that by 2, and you take 26 off of each side. And if I divide that in half, 13, so 13 thou. I should leave 13 thou on each side to go. These chips are better with the lighter cuts anyway. $549.7. Okay. Gives me 24.7 to go. Divided by 2 is 12.3 per side. So I'm going to take 12 and then see where we end up, and then we can always come back with a file and clean it up if needed. Okay, shooting for 525 or just a touch over. Let's see what we've got here. We're at 526 and a half. 526. Okay, that's good. Let me grab a file. This is a long angle lathe file. And we'll just clean that up a little bit. There we go, right about 524, 523.8. That should be just fine. Yeah, 524.85, so we're just about 525 there. Okay, that's good. Okay, the next thing we need to do is turn the rest of this down to 7/16. Now, the 7/16 number isn't magic. I just have a collet for my collet block for the lathe that's 7/16, so that's a convenient size that will fit through the bore, leave lots of material so it'll be strong and easy to turn, and it will fit the collet so I can put the flats on the end of the drawbar. Now, we need to leave a shoulder here of 200 thousandths. And again, this is not critical. It just can't be over 200 thousandths. And this is the register to fit it inside the end of the spindle. There, 200 thousandths, that should be fine. Go to mark. Now we've got 525 now, and we need to go to 4375. So we've got 525 now, we need to go to 4375, which means we need to take 87 thousandths off total, which means we need to take 43, 44 off of each side. So let me make a 20 thou pass just to get most of the material off, and we'll split what's left. Okay. Okay, we don't need a square shoulder anymore, so I'm going to go ahead and put some lead angle in this tool to make this easier. Sure I can reach where I need to get. Oh yeah, I got it easily. Okay. 20 thousandths pass. And we're at 4/8/23. Which means we've got 44 thousandths to go. Divided by 2 is 22 off of each side. We'll take that in 2 passes of 11. Here's 11. 464. Head for 4375, that's 26. Divided by 2, we need to take another 13. And that should put us right there. 10, 11, 12, 13. Four, 3, 7, 2, 5. That's pretty good. Out in the middle, we should be a little bigger. Yeah, 439, just because it's starting to get flexible. Okay, let's get a file and see if we can make this a little more cylindrical. Yeah, we're good there. Out in the middle, we got a couple thou. Okay, that looks better. Just a little bit more out here. Four, 3, 6 1/4, and let's just see what we got on this register finally. 524 looks like 523.6, something like that. $523.7. So I think this is going to be great. 523.9. Yep. So I think that's going to be fine. Well, at this point, we've got basically two operations left. One is to, in the lathe at least, one is to flip it around and finish the head, and the other is to chuck it up and turn the threads on the end. And I think I'm going to start by flipping it around and finishing the head. Okay, let me pull this out. It is a little warm. And we're going to turn it around this direction, but in order to do that, I want to put copper soft jaws on this thing. I don't want to mar up the pretty finish I got on it. Let's see if we can dial this down enough to grip it. Oh yeah. Okay. Grab an indicator. And we've got a ways to go here, so. That's about half a thou. I can live with that. Carbide tool. I'll get it more or less squared up. That's 375-ish. To make this whole thing easier to do, I'll just set a dial indicator at 0. Great, now we've got to remove a bunch of excess material. Do it in smaller passes, looks like. Can I get in here? I can. $427. Means I'm going to take 52. So I was within 2 thousandths where I set this dial indicator, just with the scale. Okay, so this head was supposed to be 375, and I set the dial indicator just using the scale, and it would have shown 0, but my previous measurement, I pushed it 2 thou past the 0. And let's see how close we are. There you go, 376.5. Not bad. Okay, I need to put a chamfer on that. I'm going to slow this way down. I'm going to grab a 45-degree high-speed steel chamfer tool. Nope, I got it right to depth and then it chattered, so. I'm going to be fine with that. There's one little detail I want to put in the end of this. I want to go ahead and put a center in it. I don't know that I'm ever going to use it, but I'd like to have it anyway. I might go slightly bigger. I think this is a number 3. Yeah. Since we have more meat than we had on the other end, we'll go with a number 3 center. Great.